Can you see my screen, Jitendra?
Yes, sir.
Okay.
Good afternoon, everyone. Now I would like to welcome Dr. Kumar Pallav, uh, as Associate Professor, Department of Civil Engineering and Geomatics, Cape Peninsula, University of Technology. Dr. Professor Kumar Pallav is an esteemed associate professor and chartered engineer who leads the Sustainable Heritage Research Unit within the Civil Engineering and Geomatics Department at Cape Peninsula University of Technology, Belly Valley campus, Cape Town. His academic journey began with a cum laude degree in civil engineering in 2001, where he ranked 10th in his university. He went on to earn a master degree in structural engineering in 2003, graduated with honors and received a gold medal from the Indian Geotechnical Society. His pursuit of excellence continued with a PhD in structural engineering from IIT Guwahati. As a passionate educator, Professor Pallav has delivered over 1,000 hours of teaching across the undergraduate and postgraduate students courses. He has guided 3 PhD candidates, 13 masters students, and 24 BTech dissertations, with several research projects currently under his supervision. His research is primarily focused on building materials and seismic hazards, culminating in numerous publications, including book chapters, peer-reviewed journal articles, and conference paper. Recently, he has filed a patent. He has filed a patent and innovative building panel design that integrates energy generation and water harvesting. Professor Pallav has played crucial role in organizing the short-term courses, online webinars, and key conferences. His expertise has been recognized with 3 European Commission grants and a recent research exchange program grants with the University of Granada, Spain. He has raised international collaboration with institutions such as UPC Barcelona and Czech Technical University Prague. Professor Pallav's leadership has strengthened ties between Cape Peninsula University of Technology and the South African Heritage Resource Agency, SARHA, promoting heritage conservation in South Africa and beyond. His dedication to teaching, research, and community engagement emphasizes his significant impact on civil engineering. Now, I would like to welcome Dr. Kumar Pallav to present his kind enlightenment on this FDP. Sir. Sir,
Thank you, Jiten. Thank you so much. Can you hear me?
Yes, sir. Yes, sir.
And can you see my slides? Yeah, my slides are visible. Can you see my slides? Just anyone?
Yes, sir.
Okay, perfect. Thank you. So thank you, Dr. Jitendra and Dr. Anjani, for inviting me for this AICT training and ATAL Learning Academy 1 week FDP on recent development in a smart and sustainable infrastructure. So today I'm going to present our recent work, which is on understanding sustainable heritage mortar characteristics for effective restoration practices. So this is the topic which I'm going to cover, and we are working on your left. If you see, this is a Robben Island on which the first president Nelson Mandela was president for 27 years. And on the right, if you see, this is a Castle of Good Hope, which is a very national heritage structures in Cape Town, and it is you can say, amalgamation of three different architecture in this, along with the material properties. So I'm going to take you through this with a very basic experiment. This is one of the master dissertation at this university under my supervision. So we were seeing how economically we can characterize a certain material, and then later on how we can develop it for the restoration purpose. So the outline of my presentation will be on introductions, and where I am going to introduce about heritage mortar, and further I'm taking you through the advancement in the field of mortar and how it has progressed through the time. Then I will also introduce and show you that problem associated with the heritage buildings, what they are facing problem right now and how we are treating them. Then cause of degradation in masonry. Then there are two major components which I will take you through. This is integrite and thumasites in masonries. And then I will show you some case studies on Robben Island and Castle of Good Hope. Right, so I'm going to the next. First, we need to understand what is a heritage, right? So if we go to the heritage structures, these are the building or site that hold significant history, cultural or architectural values, and are considered important to preserve for the future generation. And they serve as a tangible link to the past, telling the story of a particular place and its people. I further add in this that this also tells you how our like engineering has progressed through all these heritage site. And I always follow Dr. Praveen's website, YouTube. I think he takes you a lot through that. I will share it at the end and it tell you about the how well we are advanced in the past, right? So we see in terms of its aesthetic culture, we see as a natural heritage, we see also as a historic religions, military history, political history, and special events. And why we need to characterize it, that is another question, and that is what this talk is all about. So it's a great importance because once you want to develop something in order to restore, you can't use any type of material to make it restore. So you need to marry them properly. Like if you go to the doctor, definitely the doctor will treat you properly. It will replace your heart with the proper another similar type of thing, like even with the blood group, if you see. So similarly, you have to treat these structures in a way that they are built in. So if you are in today's date and you are treating the structures which were in 1980s, you can't treat them with the today's material. Means you can, but you need to make sure that those materials will properly you can say align with them and properly align with their properties, right? So by analyzing of original cementing material, it can help you to see compatible and long-term restoration of the heritage building. And how is design of heritage mortar is done? So that is what you need to see. You need to analyze it aesthetically, means it should look similar to what the material was. It has to similar kind of physical property. Then it has to be chemically, you need to know what are the material that has been added in this. Mineralogical, you need to look for it. And then mechanically means is you need to also check its strength uh, of those materials. So we follow some of them from realm. This is a quite a good guideline for restoration purpose, and this is really readily available, and if you go through those websites, right? And then we also see this compatibility and durability aspects. So I'm taking you to through the how we have advanced with the time and how this mortars and materials comes into existence. So if we go back to this backs to 8000 BC in Mesopotamian and Babylonian era, where mud mortar were used Further, if you go 6000 BC in Greece, right? So that is Dimini and Sesklo, where mud mortar with the straw herbs were used. And I think in between we were existing while we are capturing. I just take it out so that we can show that the earliest documented use of mortar in Indian history is linked to the Harappan civilization, also known as Indus Valley civilization, dating back to around 3300 to 1700 BCE. And then here you can see again, I have mentioned it, Harappan, then Devian, then Aristotle, and then Theophrastus, and then Pliny. Till this, we have came to the lime, and this lime is still in use for various restoration work, and lime mortar is still in use. So up to this second century during Roman period, we have introduced pozzolana in it, and then high lime pozzolana mortar has introduced between 4th to 5th century during the Byzantine era, and then mortar with lime added with crushed brick in 15th to 19th century during medieval Greek. So this is Colosseum which they built. They have Mohenjo-daro, their great bath if you see, and then this is Babylonian Hilla in Iraq. So I always insist that whenever you go and visit any site, you need to be very like active in order to understand how these things has been built. What are the engineering tools which they have during those times? What are the material which is locally available to build those things? So while doing any sort of, even in the modern construction, you need to look for all those parameters. Now you see we are moving towards the sustainability, and what sustainability is, you need to use your resources in such a way that you can't misuse them, and then you need to leave them, like you need to think about the future generation which is going to there. So we are using a lot of natural resources, and that's what we need to think in that way, the way our ancestors or our you can say great engineers were there. So what the problems with the heritage sites is, if you see in this, it's a Robben Island, it is Karamat, which is there. And the mortars, and if you see, this is peeling off from the wall because of it is, the location is close to the sea, and these are the problems which you can feel. It means moisture movement problem, because look what has happened, that they have treated with the cement, PPC, etc., and the moisture absorption of the lime is much better. Lime mortar is much better than your cement. Cement, once it is fixed, it is porosity is not there in that, and that's the reason most of this site was after treatment also they got deteriorated. So you need to treat them with the almost similar or same kind of material, right? Let's move to the next one. So if you see this in this cementous repointing, means the mortar, cement mortar, means this comes out of it, right? If you see, and then slowly deteriorates. So your cement mortar is harder. Like if you see, it has started deteriorating the material which is older, like brick, which is there. But if you make a mortar which is harder than that, and you treated them with that, definitely it will try to deteriorate that material. Similarly, if you see, if you use the hard cementitious material, loss of permeability of the joint will occur, loss of original character and color scheme of masonry will change. So in this case, if you see, restoration was done, and in that case, what they have done is they have used a quite a strong hard cementitious material for the pointing and repointing of this. So both way, if you see, if you treat with the you can say stronger thing, and then what has happened, your material inside is weaker, it will deteriorate, right? So now I'm taking through you the study which we have done in the South Africa. So this side, if you see, the Castle of Godop, which was built during 1666 to 1679, and and it is known as Castle de Good Hope, which is a Dutch name, and was a bastion fort for 17th century. So these are the bastion. If you see, these are pentagon shape, and the if you see the outer part of it, this is a bastion, right? And this is one of the South African national heritage site. So this structure was like constructed in stages with no specific property of castle original mortar have been characterized and documented. So what nothing was recorded for this particular thing. So that's what we want to keep a record of these material so that in any case of restorations, they can use a similar kind of mortar and they can treat them. So if you see on this figure 8, right? If you see, this is what they have treated with the modern repair mortar, like they have used PPC. And this is still the old one, which you see on the right-hand side of it, right? So this has entirely changed the aesthetic part of this structure. And what even happened in this case is soon after this repair has been done, the with the cement, because of porosity, like this walls breathe through the lime mortar thing. During rainy season, they absorb moisture, and while there are dry season, the moisture goes out of it. But this doesn't happen in the case of once you do it with your cement thing, right? So what has happened, they pop it out, the repair which has been done, because these walls are very thick, and what has happened, because of this permeability, they try to throw the material out of it, right? So that is a major problem in this type of treatment which you do for the restoration purpose. And it also doesn't look aesthetically nice for structure of that you can say national importance. So we can go for the next one. So the cause of degradation can be characterized into, you can see, five categories. If you see, compatible issues is there, then masonry unit hardness issues is there, then there is a chemical process, there is a altering natural process, and there is a moisture transfer problem. So if you talk about the compatibility issue in Europe and the United States, if a building was produced prior to late 1800, it can be assumed that traditional mortar was used in masonry construction. And if the building is between 1800 to 1920, they have very specific guideline in terms of treatment of these type of sites. And that is what we are missing in terms of our national codes in India. So between 1880 to 1920, it is typically find various combination of lime and early cement. And then that is what slowly, as we progress, we introduce Portland cement base. So that is what you need to understand when the structure was constructed. And based on that, you need to move forward with the issues. And if we talk about like altering natural process, like original mortar can retain the trapped moistures. That is what I was speaking. And geoparadising its integrity, while historic lime mortar has natural ability to heal fissures and within itself. So with the lime, if some cracks has happened, they with the moisture they get interlinked, and then what they do, they chemically heal those. You can say self-healing sort of arrangement is there. So those are like you need to understand while you are treating your things, right? And there is a definitely once a site is there, and typically if you see our case study, which is in the like we coastal regions, we are very close to the sea, and there is a significant rainfall, like winter, we are in winter season, and there is a rainfall during the winter season, and that take cares of like problems associated with this with these sites, right? Further, if you move with the production of how this two chemicals, which are very important while we were discussing the repair and maintenance of this. So what I have highlighted is the formation of intrignite is linked me also. You have muted me also, right? So it's fine. What I was explaining is that this formation of ignite is very important to understand it because it's linked to its expansion and swelling, loss of strength in cohesions, right? So, so what is happening for intrignite production to occur? The following conditions are necessary. So if you see, this is a gypsum which is there, right? So from the brick, it got from sulfate salt, and I don't know where the pointer is. Yeah, from the brick you get it from the sulfate salt and the lime mortar in, and from original masonry mortar, gypsum as a binder, and from mortar or injection of previous restoration work, gypsum as a binder. So these all is contributing while, because this historic structure has been repaired from time to time, right? So um, these all is contributing towards the CaSO4 to H2O, that is gypsum. And similarly, if you see, this is hydrated calcium aluminate, which comes from your hydraulic lime or pozzolana, and in restoration material from mortar or from the grout injection. And then once the moisture is added, you see 20 times of S2O is added, then they form this particular thing. So basically what I'm trying to explain you here, the presence of sulfate in masonry and the presence of calcium aluminate, right, in repair mortar, and then the presence of moisture in the masonry, these all get added, right? And once they get added, they form a compound. If you analyze it, I have taken it from this Valeries et al. 2003 paper, which is a very old paper, and they have very well explained how these mortars get like swelling and expansion property, and due to those how they lose their strength. So this is how this particular compound get into this mode, these structure where the joints wherever you have repaired, and that leads to your expansion, swelling, and loss of strength. So that is one thing where your heritage or heritage mortar get problems, right? Similarly, if you go with the thumacite, thumacite production in following condition, again there is a like sulfate in masonry, and here you also come with the silicate in the repair mortar, and then that added with the moisture, and these three, once it is there, can result in the formation of thumacite. And the thumacite production does not cause significant expansion, but after formation, the mortar loses its resistance property and be transformed into disjointed mass in the presence of moisture. So here I will show you in the next slide that how those things happen. So here you see again the gypsum that is all coming from all this, and then the silicate which is there in this it is coming from either hydraulic lime or hydration of the cement. Okay, so this is again from the same paper I have taken. So if we move further, this is how the severity of thumacite attack is. You see, it has deteriorated, it has came out slowly, although you have used very good quality. So whenever you walk through all these heritage site, you will find such type of uh, visual appearance of this masonry walls or masonry things. You will be come across with such things, so you should understand that it is because of the thumacite's attack, right? So we can move forward. So while you want to prevent all these things, so you need to understand these three aspects. sulfate resistance binder are utilized in the binder. So you need to see whether you have used those binders. Prevention of water from penetrating the wall, that is also you need to look for. And surface can be treated with hydrophobic product like silane, right? You should treat your surfaces with silane so that moisture cannot be penetrated within the mortars, right? So in the like absence of water, neither entry guide and thumacite cannot be formed. So if moisture is you prevented, I think you have solved 90% or 80% of the problem. So that is what this treatment of this particular wall is required periodically, right? So surface can be treated by some hydrophobic products, and that products I have given one example in this, right? So let's move further. So understanding heritage mortar, this is what I'm going to show you our case studies. So in this, what we have done, what cementing material like type of binder, aggregates and additives was originally used for the construction of heritage building. That is what we need to understand. Then characterization process assisted with the design of replica material. That is a current project. That is one of our doctoral student is working on it, and I think she's already finalizing that results now. And if we go to the Hukova's studies, like he mentioned that it is important to characterize not only the historical building material but also modern material period to the restoration. So wherever you are going for restoration work, you need to definitely characterizes. So there is always a very good questions. There is a question is rehabilitation and conservation. What is difference between these two? So you need to understand that for rehabilitation, you can demolish the structure and you can recreate the new structure on it. But conservation, you are very much restricted. You can't take material of it. That is one part. Even doing research in heritage, I think you need to take a permission from ASI to take any sort of material from the site. You can't even like use your NDT test or this means unless until you have a very specific permission on these sites. So conservation is more difficult than rehabilitation. So you have a lot of limitation before you go for the conservation of the site. So in this case, at in South Africa, I'm still little lucky because we are having a good collaboration with the national body, and we have access to almost all the sites where we used to do the research, right? So again, I'm showing the same thing. The philosophy, the which I'm saying that authenticity, like the way we have used this word, is very important in this. So we need to use that word in terms of making your mortar, right? And that is what the authenticity word is used, and its form. Like if we say authenticity means form and design, material and substance, use and function, tradition and techniques, workmanship, location and setting, and spirit and feeling, and other internal and external factors must be taken into account. So each of the aspect can be looked after according to the various traditional dimension, which is part of social, and those are traditional Western way to looking at values of architectural heritage. And this is the image, like whatever I'm quoting from the realm net image that. So if you want to characterize, it's not about only heritage thing. You need to look for all these aspects, right? So if you see, you need to look for aesthetic property, you need to go for physical, you need to go for mineralogical, chemical, and mechanical, right? And there are further advanced tests, but these are the most important aspect with that you need to look for. So if we talk about aesthetic, if you go down, it definitely shows you visual appearance, which shows you color, texture, surface finish, right? And even it further goes down, it shows the compatibility material must match with the above or closely match with the with your original mortar. Okay. Further, if you go to the physical, you have a porosity, then you have a sieve, analysis, density, frost resistance, and then water resistance, right? And you need to determine the aggregate type. And this is basically if your physical, like if your mixture or whatever aggregates or whatever you are using, that will decide. They are very much linked with the mechanical thing. So your indicator must be very close to that. If we talk about mineralogical property, this is very much do with the surrounding environment. So why we try to find the mineralogical property is the degree of hydration and the presence of minerals. And once we know how the minerals are, it plays a very important role in a way a mortar behaves and react with the surrounding environment. So you should understand that how your aggregate or whatever the material which you are going to use, it must be in line with your environment where the surrounding you are using your material. Further, chemical is going to show you the composition, what composition it is, and then it identify the binder use and its quantity. So that is what your chemical properties reveals, right? And mechanical, as a civil engineer, we know we need to get its strength and stiffness, and that will help you to see whether your material is well suited for the site where you are going to use it. So definitely, while you are going through any such work, I think you need to get all these property, whether it is modern or whether it is your heritage site. So while you are going to the aesthetic one, I've already mentioned what you need to go for. We So in this research, we were trying to go with the very you can say basic test which you have done it at your 10th 12th basis, because look, nowadays we are definitely advancing, but we need to see our resources, right? If you go for the high end test, definitely the cost is associated with those tests. But in this what we have done in this research, we have taken like some parameter. We try to optimize our studies, right? So if you see, we have categorized into A, B, C, and we want to select our test for the aesthetic one. So if we go with the aesthetic test, we have a cohesion, we have a color test, which is colorimeter, we have optical microscope, we have a visual investigation like color charts, right? And what we have done is we have seen these parameter like A, B, C, D. And if you say time taken to conduct the test, that is one parameter which we want. So I always suggest my student that before you take up your research, you need to understand that what resources you have, how much time you have, those things you need to take into consideration. And then availability of testing equipment, you need to even see that whether the equipment is there with you or you need to go somewhere for that test, right? And the quantity of material required for a test, that is another parameter. The technical data quality, what, like if you do the test, what is the quality of data, what is the precision of those data should be there. This is very important in order to understand. So if you go for SEM analysis, I think that will be very precise, very close to your thing, but definitely the cost associated with that will be very high. So here we are looking all those parameters, right? The ability of the method to give information on the mortar composition. So our target is mortar. So we are looking into the mortar details of it. Okay, so if you see for the aesthetic one, these are the tests and it take less than an hour, right? B, it is cohesion none, like cost associated with this nothing, because you need to just touch with your hand. That is fair, fair, low. And then C is availability. Yes, whatever we have written yes. We don't have colorimeter, we written no. So these are the yes. Then how much quantity you needed? Not more than 10 gram, less than one. Then E is the technical data. We get adequate data from it, right? And then the ability of method is, if you see F, it is yes, I will get good information. Colorimeter gave ability to give information about, it doesn't give the composition, F, no. It gives some, yes, and this is yes. So here we have also mentioned about its advantages and disadvantages. So suggestion is, whenever you take any set of tests, you need to look into all these aspects before you continue with those tests. So this is one stereo microscope which we have. We have done those tests, and this is how we classify our material. I haven't shown the site from where we have collected, but we have taken almost 9 samples from the sites, and that is Castle of Good Hope, which was aged in 1666. And here we also seen that there are some places there is a plaster we have taken from the floor, there is a bedding joint, these are all bedding joint. So based on this, we have characterized it like whitish mortar with black and reddish aggregate. Doing cohesion test, it's a tough, like with your hand, whether it can be easily break, you can check those things, and the description you can write it. It's just like through eyes, and even through your microscopic thing, you can check what type of material you have, right? Now, similar thing we have done with the physical method. So if you see the physical method, we have a frost resistance, we have a moisture content, then we have a permeability, we have porosity, scanning SEM you can do, sieve analysis you can do, sieve analysis on dry you can do, thermal conductivity, water absorption test you can do, right? So here we have just done one test, that is sieve analysis, and because of you see most of the places we have written no, we have moisture content, we did this test later on, and you see no, we don't have a permeability, we don't have porosity. We did porosity, yes, and then we don't have scanning SEM, means I don't say we don't have, but we don't want to go for any high-end test in this case, right? That is our aim, that we should do the testing in most economical way. And I'm telling you, with this masters, we have published 2 journal articles, and we have also published 2 conference paper with very simple test, which we have done at our place, right? So you can see this, and I can show you the results of the sieve analysis, which is for all the samples. We can't do it for SK4 sample because of it's the very less quantity. So the grain size distribution curve for all this has been plotted, which shows that it is from the passing through 4.75 is 100, and then later on it goes on decreasing, right? So next, as I told you, mineralogical property, that is also quite important that we need to understand. As I said that once you know the mineral, you know that how it is going to behave with the environment or the surrounding environment, right? So this process is used to assess the degree of hydration and present quantities of minerals such as calcium hydroxide, then calcite, quartz, gypsum, albite, uh, muscovite, that is KAL2, AlSi2, OH, FAOH. And the mineral plays an important role, and I have already mentioned how mortar behaves and react with the surrounding environment. So if it is a sea environment, how it is going to work with, and if it is in dry region, how it is going to work with the moisture, how it is going to work with. That is what how this mineral logical property will give you. So again, we have various tests. We have shown all the tests, that is differential thermal analysis, and these are like very good in the time and other things, like it take 1 hour, and if you see ion chromatography can take up to 24 hours. thermogravity, gravimetry analysis can take TGA. It is very high-end test and expensive lab. You see, we have already quoted all this. Highly sensitive, high accuracy in few minutes. Then cost is also given, right? So how much material you required. So these if you prepare such things with you, I think that will give you great idea while you are conducting your work, even at undergraduate level and master's level. So we have went for the titration. You all know that very means you have done at your 10th 12th level, and this is qualitative, not quantitative analysis. So we just know what is there, but we don't know how much it is there, right? So for that, you need to definitely go for higher end test, right? So, but the that is what your aim of the project needs to be very clear. Whether how deep you are going in that work, that has to be clearly stated, right? So here we are just trying to find out what minerals are there in it, but we are not going to find out how much it is. So we just have to derive it in terms of qualitatively, right? So we have selected this soluble salt analysis, and I can show you the results of it. So if you see the salt content in mortar, where we have used dust or binder in it, which is less than 0.063 mm. So if you see +3 sign will indicate that presence of iron as a principal component, and wherever you see less and dash, that is absence, right? So if you see, if we take sample SK1, the mineral which are present in is sulfate, and that too in the, like principal component. And if you see +2 thing is indicate a notable quantity, and if you see plus minus means indicate the presence of iron at the limit of perceptibility, right? Perceptibility, right? And nitrate is absence, and then carbonate is just indicate the presence of iron. And notes on carbonates, there is nothing. Those are all absence in it. So this is very, you can say, very basic test which you can do in your chemistry lab or in a place where you want. And you can give a nice presentation, but all your things must be well, you can say, defined. Why you have selected, what are the reason behind it. So basically we want to go for low cost testing, and this is what we have gone for. Similarly, where for the greater one, it has been shown for all the samples, like where aggregates which is greater than 0.063 mm, it says that sulfate, chloride, and then you can see carbonates are there. Now if you see wherever the size is greater than 0.063 mm, you have carbonates presence. And we have also denoted that smell produce, smell color change from whitish to blackish residue, smell produce, smell produce. So there is sulfate, there is chloride, and there is no nitrate till SK8, and then SK9 is having some amount of it, right? So in this way you can present your minerals in presence in your work with very simple titration test. But yes, for quantification, definitely you can go for somewhat higher things, right? Jitin, just let me know how much time we have left so I can continue in a pace so that we can complete in time.
45 minutes.
Okay, so we have left with 45 minutes, definitely, sure. So once we go with the chemical properties, you need to, as I mentioned, that chemical composition you required in order to understand.
20 minutes and
Yes.
20 minutes for question answer, sir. Queries.
Okay, so we can go for like another 20-25 minutes, and then
Yes,
there
yes,
is a
yes, yes.
yes, no problem. That's what I want to just know. So chemical composition of the like historic mortar, we need to understand that the binder which we have, what chemical properties it is, right? So its quantity and the binder to aggregate ratios are identified, right? So again, what I suggest is we have done the same thing for the chemical. We have used it for all the tests. We have tried to optimize those tests in order to on our resources and based on our time of doing those tests, right? So again, here we have used titration of an element oxide. We have, you can see the chemical, you can go for AAS, which is atomic absorption spectrometer, which is very expensive, time consuming when preparing the sample. Then you have a hydrogen potential test, right? If you go with this, it is like less than an hour it can take. And but it doesn't give you the complete information. Technically it is easy to perform, but it doesn't give you good information. Then you have a induced coupled plasma ICP test, that is 1 to 2 hour, which is high. You need 1 to 10 gram adequate, and this is what expensive lab equipment needed for ICP. X-ray, definitely XRF, you all know that is expensive experiment, but definitely it give you high accuracy and easy sample preparation. So less than an hour. So in this case also we went for the titration of the element oxide, and we done that test. So if you see cementation and hydrolicity is the status of historical mortar are some of the important aspect to look during the characterization process. So while doing your chemical analysis, that is what we need to understand. So your European standard like 4591 that says a natural hydraulic lime NHL were classified according to the CI index. This is what CI index. Firstly, Vicard, Vicard apparatus, we already use it. It was suggested by Vicard in 1837, and it's a method to predict the performance of hydraulic lime based on the likely hydraulicity, which is HI, of the raw material of the binder. So if we see this, if we talk about the historical mortar, which were typically you can say made of a mixture of lime, sand, water, right? And sometime include additional materials such as you can use crushed bricks and or potteries. And over these like time, what has happened, they go for the process which is called cementations, right? Where the this lime going to react with the atmospheric CO2 and form calcium carbonate, CaCO3, right? So and so in this index, we try to find out that how much B by A ratio, how much HI is it, and how much CI it is, right? Cementations. So all this SiO2 is silica, then AlO2 is Al2O3 is aluminum oxide, ferrous oxide, which is nothing but your iron oxide, and then calcium oxide and magnesium oxide. And HI is nothing but if you add silica plus aluminum oxide over CaO, that give you HI index, that is hydrolicity. So if you say that hydrolicity, what it is basically, it gives you the status of historic mortar, and means it's provide you how much it is going to register, how much resistance is going to be offered. So if we see that some historic mortar contain the hydraulic component such as you can say volcanic ash or brick dust, and that provide strength and resistance to whatever the water is going to be there from the damage. So understanding this CI and then hydrolicity, that HI in mortar will help to understand the conservation and preservation of the materials, right? So hydrolicity is a property of lime basically, and cement to set and harden underwater. So how it is going to set and how fast it is going to set underwater, that is given by HI, right? That is what hydraulicity is all about. And cementation is nothing but presence of your lime in it, how much it is there, right? So this is very short lecture, so I can't explain you in much depth, but you need to understand that this component will give you how the lime is going to set underwater, or under the moisture, right? And this is going to tell you about the lime, right? So if we go through all the samples, if you see SK1 to 9, that B by A ratios are given, which is point like binder by aggregate. That is what how much binder you have used over the aggregate, and that is 0.53, then 0.25. So here, if you see, binder is less than aggregate, right? Here, if you see, it is zero point 0.5, so binder is on the higher side. Then sorry, it is half of it, right? It is only 1/4 of it. So if we take in that way, SK8 sample is having very less, right? Means it has more aggregate than the binder, right? So similarly, all this HI and CI has been taken into care. And this is all, you can say, the very basic test which we have done in the lab of chemistry or chemical engineering, wherever you have. So it also tells you about very little clay, around 8%, very little clay, around 15%, around 8%. This is, so binder type also you can define by using it. And it is, if you see SK9 is a natural or port, means if you see SK7 and SK9, these are the two samples which they have use class, like you can say PPC during the process, right? So if we want to develop this particular material, right? So we need to understand about its formations, like aesthetic, physical, mineralogical, and chemical. So that is what we have developed for one particular site, right? And which shows that how the sieve sizes, how the binder is, like slightly hydraulic lime, then aggregate, how it is whitish coarse sand, then additives, seashells has been used, B by A ratio is given, so you can mix your mortar in that sequence, right? So further color is also given, that is whitish gray mortar uh, with fine gray, with fine black gray she shells. And then notes also we have given at the bottom is uniform graded material with very low clay content and no organic content. So this is what we have developed for all 8 samples, and this is like very helpful while you are going for a restoration work. So if suppose some consultant come or some site has been damaged, if you know the material property of that particular site, at least, I'm not saying you can use the same material, but you can definitely use a similar kind of material in order to restore those site. But this is the only case, like if you are treating your national heritage site or the site which is of importance, right? So I'm also sharing my the student who did this work. So she's a Dr. Mapole. She worked with me for masters as well as doctoral work, and she has completed her work, even doctoral work, right? So she's now Dr. Mapole, which she does in masters, and this development of the mortar which we have initiated is the next phase of the work. So this, up till this point, we have conducted our master's work, and from here the project is conducted by you can say development. So if we talk about development of the mortar, and that is design and development of that. So what we have done is we have followed European standard and the realm standards in this case. So definitely, if you visit any European site, they are very well maintained and very well taken into consideration. And if you see, what we have done is we have divided our work into two phases, right? In phase one, we have the original motors, right? In phase two, what we have done is we have taken new motor design, right? And then in development phases, again, once you have developed this motor, again you need to go for the test which is already done for the physical ones. You need to see whether how close this is with your uh, developed motor. So in this case, we have three, you can say, centuries material, which is 1600, 1700, and 1800. And that too, we have plasters, we have renders, we have a jointed. So while there is the only thing which get changed while you develop a new motor, you need to see its compatibility, right, with your the site for which you are going to develop. Durability means you need to see whether with weathering actions how your developed motor is going to behave. So definitely you need to go for some test which is like your acid test or alkaline test based on the environment in which your material is going to be used. So how they are going to behave with the current situation where you are going to place your motor, right? Similarly, you need to test physically, chemically, mineralogically, and mechanically. But while you are developing this motor, I think you need to go for higher end test, because here whatever you have done so far is not sufficient to develop your motor. So you have to look the you can say the quantity, right? The quantity of how much quantity means is there. Once your mineralogical property, you need to quantify it. So what is the percentage of calcium carbonate? What is the percentage of silica? What is the percentage? So once you get those percentage, right, then you can do the motor design. Means already there are several literature which reflect your motor design, and then based on those literature, select like what ratio you need to go for, right? Currently, one of my student, honors student, is working on, like, we already developed this motor, but we are trying to improve its durability aspect with the help of some nanoparticles. So that comes in this particular phase, right? So this is like very tedious work while you are going for a development, because you need to very well develop these all these motor type, right? So I think I would like to go for this conclusion is like heritage structures are very important and they need to be preserved with the authenticity of the materials, right? And then attention must be paid to prepare a catalog of materials used in different eras. So this is a project which we are doing with the University of Granada. And currently, even I am also collaborating with IIT Jodhpur with one of the group there who working with the material. And we are trying to prepare a big catalog of materials which has been used from century. Means currently, I think I'm just taking a South African context because there is not much of it. But if you see the European context and even in India, I think very few studies has been done till now. I have seen NIT Trichy has started. I saw some of the work which I reviewed it, They have initiated, but still there are lot of scope while we take some sort of research in this. And if you see in India, what we are doing currently is we are even using PPC and cement for we are we are doing rehabilitation rather than conservation. So some of the site they completely try to make it in the same way, but with the new material. So yeah, that is all choice of the you can say the body, in what way they want to do the conservation, right? Further, any rehabilitation of heritage structures must be made only if there is a full certainty that the eventual repercussion of such element introduce a under, fully understood. So, if you fully understood that structures and if you can replicate it nicely, I think then only rehabilitation can be done. Else, I suggest we can always go with the conservation aspect of the work, right? Further, if we move on, is if you need a multidisciplinary approach in this case. And why I'm saying multidisciplinary approach, it's not about only material, but you need to understand your community, which is going to be in the surrounding. And you have to see in terms of like nowadays we have a, uh life cycle assessment analysis, like sustainability. You see, you can also see the energy efficiency of your heritage structures. So I think I have put one master's work on this energy efficacy using like three softwares. I think those softwares are also not means the student version can be used. We have done one recent work on that. We try to integrate three different softwares like building like Revit, then Device, and then other another one. So we have used a quite multidisciplinary approach in doing such work of conservations, right? And then the last one which I want to reflect is primary material card. Means you can prepare a nice card for all these sites, and it is good to have those cards in order to give your authority that look, this is what we have done, and then you can use them for the restoration work. And further, it is up to the engineer to design intervention that avoids investigation and come to the medium between being loyal to the original layout of the structures while assuring the adequate level of safety and durability. So basically, it's basically on the authority, and the engineer in charge take a lot of decision while you are conserving those sites, right? So I have few more like heritage structures are very important and they need to preserve with the authenticity of the material. And attention must be paid to prepare a catalog. I think it is repeating, sorry. And then I need to acknowledge, I think we got different fundings. This is one African Heritage World Fund, and even UNESCO used to fund. You have to just write those things. And then we have Cape Peninsula University, where they have given a research grant to the student to for the exchange. We also thankful to Sahara, that is our collaborating body, which is national body, who help us to access the site. Because yeah, heritage site, you have to be well permission to visit them, because touching anything is I think it's like a vintage sort of thing. You can't take anything from there. We also thankful to Castle of Good Hope. That is a castle which I have shown you. And then the Spain, the university which help us to do the analysis. And then these are the research group which we have joined in Granada. Andalusia is nothing but Granada's name, right? They take it in that way. And I thanks to all of them. So thank you for your patience listening, and I'm available for Q&A session. I think this should be good. You should ask more questions. If you understand, if you be quiet, I will be happy in that way. Yes. Thank you, Jitin. Thank you, Dr.
Uh,
Anjani.
Very thank you to our Dr. Kumar Pallav sir. Extremely thankful for your kind informative sessions. So, sir, I had one doubt, sir. When I was doing my research, so when I was because from I am from a civil engineering background, so generally what happens that we researcher feel that everything in the civil engineering has been discovered. There's nothing which we can do the research and so sir, can you tell us sir, what are the new areas where the new researchers where they can start researching?
Yeah, I mean, this is very good. Means, you see, I can tell you, I met
Yeah.
one professor in Norway. Can you imagine? He's researching on the bolt thread, and he is
Oh,
thread of the bolt. Can you imagine? And you can't say that the thread of the bolt, you can say that the research has been done. No, you can't. It means you can take anything and the research is still you can do on that. I'm not sure who has said you that the research is already done, but there is so deep in it. Means I even not knowing this entrigite and thumasites. These are the component which has been developed during the moistures, right? And I'm not sure that these are playing a role in the strength deterioration of the mortar. So only once you go deep into it, means that person I was asking how, like he's doing 20 plus year of research in only bolts and its thread. Yeah, so
yes,
you can, I can suggest you, there is a AI tool which are coming now. You have a building information models, you have a Revit, and one of my student, I will share it with you. You don't have to go for very high end research. And we have presented that paper in one conference. He got a best paper award with a very basic level research on a recent technology. He has integrated three of them. And look, nowadays you have open source softwares, you have AI with you, and even you have a student versions of softwares. Means every softwares which you don't have at your institutions, I suggest try to use the student version of it and try to explore those versions, and you can do the research. Means we have done that btech research on the student version of that softwares. So see the limitation of the softwares, and I suggest you can take any of the research. I showed you this because I know the titration you can do it in your lab.
yes,
You
sir.
don't
So
have to
this
go out,
was
right?
really
So that is the
informative. Means
reason.
a
I mean,
lot
I
of
could have shown you all the same results, and I can even show you. Means we have those development results, but I want to show you that you can do your research with your 10th and 12th standard test. But my suggestion is you need to show why you have chosen. So I always go with the low cost, time, and everything, because I told you with this research we have published two journal article, and that to Q1, Q2 and Q3 status. Okay. So Jitendra, don't be disheartened. Like you can do, means I'm not sure who has said you that this has been covered. You can take any area where you are good in that, and you can start your research. And as you read more, you will get more.
yes, sir.
You know that, right? If you
Actu-
read same book
yes, sir.
several
Actually, sir.
times, you get new
Actually, sir,
ideas.
when I was thinking about some filing some patent in civil engineering topics, so I started searching for those what are the areas which we can have patent. So this problem arose in my mind that most of the areas means for example cement. So what new we can do in cement is already so much research has been done. It is almost like in perfect state. So
Look,
and
I
I
can show
haven't
you.
seen much research in this last 10 or 20 years.
I think nowadays people are seeing, look, you need to reuse. like circular economy. You can
Yes.
think your research in the circular economy. Like you see some waste which is there in your locality, right? And try to use
Yes.
that waste either in the case of pavement, or either you develop some construction material with that, and that could be patented, right? If you optimize it, it can be patented. So people are doing research. Like I will share you one of our means faculty from NIT Agartala. He's HOD there in civil engineering. He's a good friend of mine. He uses bamboo a lot, and he has developed one brick binding machine, and he patented that, low cost. So I can tell you, just see your local thing, whatever is available. See the simplest way you need to develop those things. I can tell you cement, you can start using fly ash or something like that. If you see one faculty from Dr. Singh from Jalandhar, I think I remember, he has replaced entire cement from one of the concrete which he has developed. He hasn't used. So as you read,
I
Dr.
think
Jitendra, I think,
I think sir, that professor name is Professor Dev Dulal
yes,
from
Professor Dev Dulal.
Tripura.
Yes, yes, yes,
Yes,
yes,
sir.
yes. He is very good. Means we are writing like bricks project with him. Like we have last year submitted, but we are again writing together again. So he's very good in like developing low cost housing, low cost. Like you should go for something which you can see your resources, and I suggest do the research accordingly. You can just develop your resources in a way you want to move forward, right? Anything else?
Yes, audience.
You can even type in the chat box. I can read it, those questions if you want.
Any faculty, if you want to ask some questions from sir.
Any research scholar who wants to have some queries regarding the research work related to civil engineering or any field, because researchers generally
Anything,
follow a
yeah,
same
means,
pattern, same
yes,
every step is same almost, just the topics
yes,
is different. So you
yeah,
can
it's
ask
a
from
great, it's what
sir some questions.
even if you want to type it, I can read it and I can answer it. I means if you want, you can just type it in the chat box. I think they are little hesitant, Jitendra. So I just want to conclude in a way that research is all about learning process. Even I'm learning today, and learning in the sense you have to see, like now I started learning little AI, right? And even I started learning little, you can say, life cycle assessment. Nowadays this is also quite a good topic in order to move your research. You can take any material and then you can do the LC analysis of that. That is what you can do. Like you have taken from the nature and you have given back to the nature while the construction process has been done. So people are doing a lot of LC analysis nowadays. That is another domain in which you can enter. And if you want to be in an analysis field, definitely nowadays the using artificial intelligence, I can share you Dr. Mayank's work, who works on a heritage, and he is using only mobile camera to take good images, and one software is YOLO. And with the help of YOLO, he is using it for damage detection. So that is the level of research you can do with the whatever the resources you have within yourself. So my suggestion is, there are a lot of domain, and with the changing world, you can say that with the change in AI thing, uh, that can be really very, very thoughtful, right? I just got one question. Can we use bamboo as a reinforcing material for flexural member? People are doing research on that. Yes, you can, but for the, you can say, the the durability of that material needs to be checked, right? For a smaller structure, but you can use it. But I think if you see Professor Dev Dulal work, I think he's doing a lot of reinforcing work, right? He's using in the masonry wall, he's using in the beam, and then even he's using in lot of places. So, and he's also filing a patent on that. So any local material, you can use it. Any other questions? It is good to type it in the box. That will be great.
I think, sir, there is no question from the audience, and
Perfect.
We can close this session and proceed for the
next session. We are closing this session. Thank you very much, sir, for
Thank you,
your.
thank you very much,
Thank you.
Dr. Jiten. Thank you very much, Dr. Anjani. It is nice meeting you,
Sir,
and I'm always.
am I audible, sir?
Yes, Verma, sir. Please ask.
Good evening, sir. I have got a small query.
Yes, go ahead.
Sir, in the older constructions, the porosity, how they had been taking care of that? Because if porosity is there in the material, that might be affecting the strength too much. So how they, in
Uh,
the olden times, they are able to take care of?
This is a very good question. Means that is what, if you see the older construction, right, the wall thickness and other things are too much, right? If you see they are a meter or half a meter of thick walls, right? So even if they use some mortar like lime mortar, which is good for like having a porosity and they can breathe. We can always say breathability. This is new term which is coming. They can take moisture from the uh, air and even from the rain, and they can expand, right? And they, that is what the self-healing property exists in that, and that is what it has been used. So you need to see like that is what I have shown you, the development of the mortar from the mud. If you have used mud, it is having a different property, and slowly they started using lime, then little pozzolanic, and now we are at cement and higher version of the material. So slowly, if you see the cement, the porosity is gone, but the strength you have achieved a lot, right? But you can't treat your older structure with the cement right now, because the older heritage structures, they breathe, and if you treat them, they stop breathing, and that is a problem where the problem comes in the heritage sites while you are treating them. So definitely, if you try to reduce the porosity, the strength will be enhanced. But in older structures, yes, because of the size, because of the thicknesses, and most of the cases, they always go for the compression member. You don't see the tension in those structures. So if you see the arches which they make, right, the thickness of the wall which they make, so they are very good engineer. They don't allow tension in their life. You see, so they don't allow tension in the structures. So that is how they go for it, right? Does I answer your question?
Right, sir. Thank you very much, sir.
Thank you. Thank
Sir,
you so
one
much.
question from the audience.
Yes.
That when we are using bamboo concrete, so what about this durability and bonding with cement? Because that is a problem, because bamboo is not
Yes,
a
exactly.
uh,
Yes.
means
Yes.
it's,
You need
it
to.
is a biological materials, and
Yes, exactly.
cement
You
is
need to.
a non-biological material, sir.
Exactly. That is what the
So it will
studies is
degrade
still in
also.
progress. Yes, the studies is still in progress in order to understand this bonding behavior. The bond test needs to be done on all those materials where you are going for it. You can't simply use bamboo as a reinforcement. Definitely, it will not going to get a cohesion property with the bamboo, right? So definitely, there are various natural adhesive which are coming into existence, and they are using those natural adhesive, right, in order to get intact So confinement, I can say the word which we can use, a cohesion is a word which we can use while we are doing the connection, or you can say with the bamboo. But yes, those study needs to be done. I think they will, Professor, they will give you more insight on it. I am not expert in that area.
Okay. Okay.
I
Sir,
just see
initially,
next
sir, we
question,
were
somebody.
using in the, yes, sir,
Yes,
sir, one question from the audience. It is
yes,
about
I see.
mud mortar.
Yes, I see there are few questions. I'm just reading with the, Mr. Alok. Sir, can we use straw with the mud mortar as a reinforcement for low cost construction? Yes, there is a research. I think nowadays they are using a lot of straw which are available on the river side in order to do some low cost housing work, right? So if you see our older, it means I went to my nani's house and I saw that mud wall. I remember during my childhood, those walls were very thick, but they have a like we call it as a bhusa. I don't know, you know, bhusa, like the husk. You can say that they use those things while mixing with the mud in order to provide some fiber reinforcement. You can say that, right? So they use those reinforcement to strengthen their wall, right? So you can use it, but yes, definitely, as I showed you all the properties, basically the physical is very important in that case. And once you get the physical, your mechanical property is also very important. You need to test them, right? So that is what you
And
need to do a look. Okay, and then another one is porosity plays an important role in thermal comfort. Exactly, means the way things will be, means you can't allow more porous, else the water will be inside your house. But yes, there should be some porosity which give you some breathability, and then ventilation and everything will be fine. Will durability be increased by well seasoned bamboo coated with bitumen? Look, you are suggesting some ideas on a research. I can't say on this. I haven't read anything on that. Bitumen is another material which you use in the paving, and I can't comment on that. Means if you coat it and then use it, whether the durability, means it's all about like the doctor. I always take a doctor and an example, and I always take God as a super engineer in any case. So you see how beautifully he has designed our eyes, nose, and everything. So similarly, you need to test this before you go for it. As you increase the
Thank you, sir.
non-homogeneity, yeah, a non-homogeneity, that will be a problem. Yes, I think we can conclude, Dr. Anjani. I think your
Yes,
next
sir.
speaker
Yes,
is.
sir. Thanks.
Sorry,
Thanks.
I'm taking
Nice
that.
questionnaire.
Thank you. Thank you.
thank you. Proceed.
Let me
We have
unshare my
to
screen.
proceed for the next session, sir. Also.
Yes.
Thank you.
Thank you, sir.
Sir, for
We
your
are
Thank
concluding
you,
this.
son. Thank you so much.
Thank you.